Hello and welcome to this new playlist, Integration for LLMs. Now, I'm covering AFs first, and I'll go onto full A-level stuff. Now, the way I've done to split this up is the first video is all about the fundamental theorem of calculus. Now, the reason why I want to talk about this first is because in the specification, for most examples, I think, if not all of them, they all talk about the fundamental theorem of calculus. So we might as well at least talk about it, right, and at least have a look at it. So we've got some curve here that I've drawn of y equals f of x. Classic curve. I don't know much about it. I've just drawn it, alright? I'm going to talk about what's going to go on here. So I can, from differentiation, I could take a chunk out and call that some value x. I can also take this other chunk of bit out and call that x plus h. Nothing new there. I can also take this area. Now this area could be some function a of x. I don't know how much that is. And we don't know. We don't have to know, do we? Now what we do know though is we've got this bit of area we cannot calculate. This bit of curve that we can zoom in on. So we've got bits of it, but we don't have the whole thing. So if I redraw this, draw that little box that I've just drawn, and I've drawn in that bit of curve, like so, I can put my x and my x plus h in, that's nothing new there. When I've put those in, I can then put my f of x, and my f of x plus h, nothing new there. Alright, now, the gradient of this line would be f of x plus h minus f of x, as we know. We can put some more brackets around that. We multiply that by h, but then we divide by h later on. Right? So we've got a limit as h approaching 0 of f of x plus h minus f of x equals 0. Right? Now this area that we had before is a of x plus h minus a of x, which is equal to f of x h, so that h is another bit, plus some extra bits, which I'll just call extra, but I don't know how much there is. Could be some extra bit, I don't know. We can rearrange, get f of x equals, we can get a of x plus h minus a of x, and divide that by h. So we end up getting that out. And we can minus also this extra bit over h, divided by h, of course. So we can get that out. Now, let's just reach my calculator. Here. Now, there is one part of the specification, again, like I say, that covers this in more detail. That bit I want to talk about is if I have, for example, a different curve. Right? So, we've got a of x plus h that we had, which was this bit, so that can go in there. The other bit we had, if I said that f of x was a prime of x, was its derivative, then my integral of a of b of f of x in respect to x will be equal to the area in itself, right? So that's where this integral sign always comes from. Alright? The integral sign is coming from summations, from summing up all these values. That's what integration really is. Anyway, let's move on to this next part of the fundamental theorem. We're going to draw a new graph. Hope you like graphs. Let's get my calc again. Let's draw some new graph. Now, what you've seen before, when we've done differentiation, is we differentiate just standard curves. Now, I might just switch pens actually, just for your sake as well, so you can see what's going on. To a green, hey? So I'm going to draw some graph again. I'm going to draw the same thing. Y equals f of x. The curve doesn't really matter. It doesn't matter what the curve is. But we had f of x being equal to a prime of x before on the board. And when I integrated between some limits a and b of f of x dx, in itself would be one area of b minus another area of a. What is the value of a? What is a? So I could take some limits of a, I don't know what that is, I can't tell. Take some limits of b, I don't know what that is. But it finds you that area. It does the whole thing minus the bit you want to give you the area. This is a summation, which is why integration is called a process of summation, of the function itself, delta x. And as this bit gets closer and closer to 0, every time you will approach an integral between a and b of the function in respect to x. So the question we have to ask ourselves now is, what is a of x? What is it? And a of x, you'll find, is the function itself. So we're going to look at this when we actually start looking at some proper integrals. This is a nice start to what we're going to look at in this section.